Welcome back to a new video. I'm Timmy, or some of you might know me as the physics and maths guru. I hope you guys are doing well in these times. I know it's been a while, and I've unfortunately these last couple of months I've been quite busy, and I haven't really been posting as much as I would have liked to. But now I'm gonna try and make a bigger effort to keep those videos up. So I found this May-June 2022 past paper, a 2-1, paper 2, and I've selected a few questions that I think I can or will go over in this video. It's going to take me a bit of time, so I'm going to try answer this whole paper over a couple parts. So this will be part 1, and hopefully I can finish this whole past paper in the next couple of videos. But yeah, so I've selected a few and let's go. So in this question, we have question 2a. So it says, express the equation 7 tan theta plus 4 cot theta minus 13 sec theta is equal to 0 in terms of sine only. Okay, so we know we're going to use some trig identities here to try convert this expression in terms of sine theta only. So I'm first gonna try to write everything in terms of sine and cos, and we'll move from there. So we know tan theta, okay, let's just write tan theta is equal to sine theta over cos theta. Cot theta is the inverse of tan theta, so it's going to be 1 over tan theta, or it's just going to be cos theta over sine theta. And sec theta, I remember I always used to get this wrong. You need to make sure it's 1 over cos theta. Yeah, very important. And then now we have all our tools, so let's try simplify the expression. So we get 7 sine theta over cos theta plus 4 cos theta over sine theta minus 13 over cos theta is equal to 0. Okay, so now I can see in my denominator I have cos theta and sine theta, so I'm going to multiply both sides by cos theta sine theta, cos theta sine theta. Yeah, okay, so now on the first one the cos thetas will cancel out, so we get 7 sine squared theta, plus the second one the sine thetas will cancel out, so we had 4 cos squared theta minus 13, and the cos's cancel out, so we get 13 sine theta, and anything times 0 just gives us 0. Okay, so we've simplified it a bit, but it says in terms of sine theta only, and we have a cos squared theta, but we know we can use the identity of, we just write that as 4 cos theta is equal to 1 minus sine squared theta, and you can find this in your formula sheets as well. So you don't really have to remember it, but it is nice to remember, so you don't have to go to your formula sheets. Is equal to 0, and then we can expand plus 4 minus 4 sine squared theta minus 13 sine theta is equal to 0. Simplify like terms, that's going to be 3 sine squared theta minus 13 sine theta plus 4. Wait, let me just check. Yeah, it's equal to 0. Everything is in terms of sine, so we've solved this question. So now let's move on to the next one. It says, hence solve the equation 7 tan theta plus 4 cot theta minus 13 sec theta is equal to 0, and they've given us limits. So just notice that the limits are in degrees, not radians. So make sure when you're answering this question, your calculator is in degrees and not radians. So when you see a hence, I think 100% of the time, what they've made you prove or solve in your mostly prove in your first part A is what you'll use. So now it's a lot easier to use everything in terms of sine theta compared to solving an equation where we have three different identities. So I'm going to rewrite the 7 tan theta plus 4 cot theta. I'm going to write it in terms of sine. Plus 4 is equal to 0. Okay, when we've noticed that we have sine squared, so it's a quadratic. There's many different methods you can use. You can use the quadratic formula, completing the square, but I normally just like to use, or even K substitution, if that's what you like. But for this one, I'm just going to use group factorization and just leave in terms of sine theta, because that's the method I just like using. And we can see 3 times 4 gives us 12, negative 12 and negative 1 will give us the middle term of negative 13. So we can rewrite this as 3 sine squared theta minus 12 sine theta minus sine theta plus 4 is equal to 0. Take out common factors. 3 sine theta is common, and then we get sine theta minus 4 and minus 1 on this other side. Sine theta minus 4 is equal to 0. Now we can say 3 sine theta minus 1 is equal to 0, or sine theta minus 4 is equal to 0. So sine theta is equal to 1 over 3, or sine theta is equal to 4. Immediately for this one, I know that there's going to be no answer here, because when I'm just going to do a rough sketch. The range of the function where the maximum value and the minimum value of a sine graph is negative 1 and 1. So yeah, I just did a bad sketch there. So sine theta cannot equal 4 because it's past our range. So we can immediately cross this one out. And even if you want to check, go into your calculator and say inverse sine of 4. And it will either say like math error or something, but it won't give you an answer. So now let's find our principal angle of theta. 1 over 3. Oh, sorry. 1 over 3. And we get is equal to 19.47. I just write 2 decimal places and I round off towards the end. So we have our first answer, but we need to remember, I always suggest doing this, draw out your CAST diagram. All saints take coffee. That's how I remember it. You can use your own method or whatever you feel most comfortable with, but this is the one I use. So we have our first principal angle, which is in this quadrant, the first quadrant. But sine theta is also positive in the second quadrant, which is 180 minus theta. So it's going to be 180 minus 19.47, which is equal to 160.53. Okay, so now we have our answers. It says from 0 to 360, and these are the only answers from 0 to 360. So that's going to be 19.5 and 160.5. Sorted. Oh, let me just make this dot bigger. Now, 160.5. Sorted. Okay, so let's move on to the next question. The diagram shows the curve with the equation 3 sine x, minus 3 sine 2x for the limits of 0 to pi, which is for x values. The curve meets the x-axis at the origin and at points with x coordinates a and pi. Find the exact value of a. Okay, so if we look at 0, a, and pi, what they all have in common, that's where the graph meets the x-axis. And if it meets the x-axis at that point, that means our y value is 0. So what we can say is, we can say 0 is equal to 3 sine x minus 3 sine 2x. Okay, so it's 3 sine x minus, and I'm going to use the trig identity of sine 2x is equivalent to 2 sine x cos x. It's also in your formula sheet, but it is helpful to remember. So 3 sine x minus 3 2 sine x cos x. Okay, so 0 is equal to 3 sine x minus 6 sine x cos x. Okay, so now we can't really solve this because we have sine x and cos x. So we now need to try to get rid of the cos x. So let's see, factor sine x is common. Let's try that. So we can say 3 is equal to 3 sine x is common for both. So that's going to be 1 minus 2 cos x. Sorted. Yeah, okay. And now we can use that AB rule that if a times b is equal to 0, then either a or b is 0. So we can say 3 sine x is equal to 0, or 1 minus 2 cos x is equal to 0. Okay. So this is when you divide by it, you're still going to get sine x is equal to 0. And that just gives you 0. So this answer that we've got, this is what gives us this point here. Okay, so now we still haven't found a. So now we're going to get, if we bring this over, 1 is equal to 2 cos x, and then cos x is equal to a half, right? Okay, so I'm just going to carry on here. So if we try to find that angle, it's in radians. Let me check in radians. So it's going to be negative inverse cos of a half, which is just, I think, pi over 3. Yeah, so that's, I might write it. So x is equal to pi over 3. And it says the limits are between 0 and pi. So we're not going to say 2 pi minus this principal angle. So that means this answer is pi over 3. So we can say, I think it's a is equal to pi over 3. Sorted. Yeah, okay. So now it says find the area of the shaded region. So when we see this question, we immediately thinking integration, and we now know our limits, which is kind of nice, and we know what we're integrating, so we can integrate with our limits of pi and pi over 3. Pi over 3, and that is, I think, 3 sine x, 3 sine x minus 3 sine 2x, sine 2x dx. Okay, I don't think there's any, yeah. So now let's get integrating. Boom. So pi over 3. Okay, when we integrate into integral of sine, it's going to be, I think, negative cos, but this is all on your formula sheet. But yeah, let me just information. I just want to just show you that yeah, formula sheet is long, but it's very useful. I've noticed. But yeah, so for integration, you can see we have sine, and when we integrate, we get negative cos. That's going to be negative 3 cos x. And then there's also other differentiation and integration, but I just want to show you just in case you didn't know where to find it. So negative 3 cos x, and this is going to be negative 3, and that's going to be, it's going to be positive because this is also negative, so that's going to be, let me just, cos 2x, and then you have to divide by this, so that's going to be over 2 plus c. Okay, yeah. Well, no, it's not plus c because it's using limits, not indefinite. So we've integrated. So now let's apply our limits. Oh, I didn't say exact area, so yeah, should be sorted though. Minus 3 cos pi plus 3 over 2 cos 2 times pi, and now let's minus it from minus 3 cos pi over 3 plus 3 over 2 cos 2 times pi over 3. Oh, that was bad. Let me just fix this up. Yeah, so all good to go. So now this is going to be equal to negative 3 cos pi. It's going to be 3 plus 3 over 2. And now let's minus from here. Minus 3 over 2. Oh, no, let me. And then minus 3 over 4. Okay, so when we bring this over, we get 3 plus 3 over 2 plus, because you have to, I'm just distributing by negative 1, plus 3 over 2 plus 3 over 4. And let's see what we get. 3. We get 27 over 4. Yeah, I think it's, yeah, you don't have to say unit squared, but 27 over 4. From what most memos I've seen, that our answer is acceptable. 27 over 4, and we sorted. Yeah, nice question that they walked us through. We found our limits first, and easy 7 marks. So the next question, a curve has equation x squared y plus 2y cubed is equal to 48. Find the equation to the normal. Okay, normal. Yeah, equation to the normal. At the point, giving us a point, giving your answer in the form of ax plus by plus c is equal to where a, b, and c are integers. Okay, so if you're trying to find the equation to the normal, what do we need? We need to know that gradient at that point, and in order to do that, we need the gradient function, and we have a point. So we need to differentiate this curve. So we have the curve, let's just rewrite it. X squared y plus 2y cubed is equal to 48. Okay, how I always like to do this is, in the first one we can see you have, or just to let you guys know, we have x and y, so we're going to use implicit differentiation. Wherever we differentiate y, we just put dy dx. But the first one, we can't differentiate straight away because it's product rule. It's a product, so we have to use the product rule. Yeah. So how I always like to set it up, I always just write u and v. So u is just x squared, and v is y. So du dx is equal to 2x, and dv dy is going to be 1. So now, basically the product rule, you just multiply these two things. Yeah, it's in your formula sheet as well if you do forget, but I do recommend learning it. It saves you a lot of time as well. So let's do this. So that's going to be x squared dy dx, because we just differentiated the y. So it's x squared dy dx plus 2xy. I'm just going to write it like that. Plus 6y squared dy dx, because I differentiated y, is equal to 0, because whenever you differentiate a constant, you get a big fat 0. Yeah. Okay, so now what my next goal is to try to get dy dx by itself. So let's say x squared dy dx plus 6y squared dy dx is equal to negative 2xy. So dy dx is common on the left hand side, so we can factor it out. Let's say dy dx as a common factor, and then x squared plus 6y squared is equal to negative 2xy. And then divide by x squared plus 6y squared, tongue twister, is equal to negative 2xy over x squared plus 6y squared. Boom. So we have our dy dx, okay? And they've told us at the point 4,2, so they've given us a point 4,2. So if I substitute this point into my dy dx, I'm going to get that gradient at that specific point. So at point 4,2, so if I substitute it, I'm just going to say, if I substitute it, then I'm going to get negative 2, x is 4, y is 2, all over 4 squared, right, plus 6, y squared is 2. Okay, so let's see what that gives us. Negative 2, 4 squared plus 6 is 2 squared. It gives us negative 2 over 5. So this is our gradients. So yeah, you can see this question isn't too bad. You just have to take it one step at a time. So we have our gradients at that point. So now, because I want the equation of the normal, we know that the equation of the normal basically means that these two lines are meeting at right angles. So if this gradient is negative 2 over 5, this gradient has to be 5 over 2. Yeah, and you can always check your answer, because a product of these two gradients has to give you negative 1 all the time. So 5 over 2 times negative 2 over 5 cancels. That just gives you negative 1. So that's always one way to check it out. So that means we know that y is equal to 5 over 2x plus c. And we know our x and y coordinates, because given us to 4, 2. So we can say 2 is equal to 5x, and the x coordinate is 4. So 5 over 2 times 4, which is going to be 10. Yeah, 5 over 2 times 4 is just going to be 10. Because the 2's cancel out. Plus c. So that means c is equal to -8. Yeah, okay. So that means our equation is, let's see, is y is equal to 5 over 2x minus 8. But then they say they want it in the form ax plus by plus c, where a, b, and c are integers. So let me just multiply everything by 2y plus 5x minus 6. Oh, wait, no. I'm jumping the gun. 2y is equal to 5x minus 16. Okay, now let's bring everything over, just like they said. So 2y minus 5x plus 16 is equal to 0. Boom. Done. Dusted. Easy 7 marks. And we move. And I think we have one more question to go over in this video. And you can see so far hasn't been too bad. I also just found this polynomial question. Yeah. So it says question 7, the polynomial p of x is defined as 2x cubed plus 5x squared plus ax plus 2a, where a is an integer that's presumably we're going to find sooner or later, I'm sure. But it says, find in terms of x and a the quotients when px is divided by x plus 2 and show that the remainder is 4. Okay, so what I'm thinking is, when you divide it by x minus 2, if I substitute, no, it says show, okay, it says show that the remainder is 4. So we can't equate it to 4. That means we have to do long division. Okay. Okay, so let's say 2x cubed plus 5x squared plus ax plus 2a. Yeah. And it's just divided by x plus 2. Okay. So how many times? So yeah, long division, very similar to what we did in prep school. It's going to be 2x squared, and then you multiply 2x squared by x to get 2x cubed plus 4x squared, and then you minus 5 minus 4 just gives you x squared. Bring it down, that's plus ax. It's going to be plus x. It's going to be x squared plus 2x minus, this is going to give you a minus 2x plus 2a. Yeah, so find in terms of the quotients. So that's just going to be plus a minus 2. And then we can't, I don't think we can simplify. We can try, okay. A minus 2. Yeah, that's going to be a minus 2x minus, and then that's going to be plus, it's going to be 2a minus 4. Oh, what a beautiful question. Oh my days. What a beautiful question. Yeah, so this is common. A minus 2x minus a minus 2x. That's just going to give us 0. 2a, let me just rewrite this so we don't get confused. So that's going to be 2a plus 4 because of the minus. So that's plus 2a minus 4. So 2a minus 2a gives us 0, and 0 minus minus 4 gives us positive 4. Honestly, for this question, I actually jumped the gun initially because I was thinking, let me just, because we know it's, I was literally saying x minus 2 and then substituted there, but it's all good. So I think this is what's going to be acceptable. Find the quotient. So let's just write the quotients. Q is equal to 2x squared plus x plus a minus 2. R is 4. Yeah. So this is the end of part 1. I hope you have enjoyed this video. I'm going to try finish out this past paper as soon as I can. But if you have any questions, hit me up in the comments. Hope you like this video, and please subscribe if you enjoy videos like this. Cheers.